Hello students, today we are going to discuss model number 4, that is irradiation chapter. So here a problem is there: a large parallel plates with emissivities 0.3 and 0.8 exchanges heat. Find the percentage reduction when polished aluminum shield of emissivity 0.04 is placed in between them. So what will be the percentage reduction that we have to calculate using that electrical analogy. So as such, you understand that the radiation shield chapter. So here we are going to find out the what is the percentage reduction. To calculate percentage reduction, we must know the what is the heat transfer between Q1 to 2 and 2 to 1 to 3. So that we must know it. Then only we can calculate percentage reduction. So let us consider where is the data is given here. Given data is emissivity. First it is given 0.3, 0.8, and this sigma 3, epsilon 3, 0.04 is introduced between them. So consider all the resistance, surface resistance and space resistance per unit surface area. So you can calculate, consider all resistance, that is surface resistance and space resistance per unit surface area for steady state. For steady state, the heat flow will be like this. That is 1 minus epsilon 1 divided by epsilon plus 1 plus 1 minus epsilon 3 divided by epsilon 3. This is the steady flow rate. So again, for certain we have to modify this equation. So this will be equals to, again, EB3 minus EB2 1 minus epsilon 3 divided by epsilon 3 plus 1 plus 1 minus epsilon 2 divided by epsilon 2. Okay. So because why we are taking, because A1 is equal to A2 is equal to A3. Initially only we have considered, that is our surface area and surface resistance, space resistance is 0. It is per unit surface area. So the following factor, that is 1. Okay. Now you can write T1 to the power of 4 minus Tt to the power of 4 whole divided by 1 epsilon 1 plus is equals to T3 to the power 4, that is sigma 2 to the power 4 divided by 1 by epsilon 3 plus 1 by epsilon 2 minus 1. So this will get cancelled. T1 to the power 4, T2 to the power 4 divided by 1 upon 0.3 is 1 upon 0.04 minus 1. T3 to the power 4, T2 to the power 4, 1 upon 0.04 plus 1 upon 0.8 minus 1. So we can calculate T to the power of 4 minus T to the power of 4 divided by 27.33, T3 to the power of 4 minus T2 to the power of 4 is around 25.25. Okay, so if it is the case, then Further, you can analyze this problem like this. Okay, I'll tell you how it is. So there are shield like this, two shields are there. So this shield like this. Okay, this is different shields having different shield. Okay, this is like this. Okay, in between third shield will be there here. Okay, this will be third one. So first one and second one, in between these two shields material, one emissivity of the shield is introduced in between them, then this becomes epsilon 1, epsilon 3, and this is a epsilon 2. This is what we can say radiation shield. Radiation. So can we draw this electric analogy for this? So very simple. First junction J1, junction J2, and in between junction J3, junction 4, okay, J1 and J3 we can say this one, and this is EB1, this is EB2 here, this is junction J2, this is J3 dash, J3 dash, this one we call the EB3. Okay, now we can write the resistance of this epsilon 1 divided by A1 epsilon 1 A1 AF1 3 1 minus epsilon 3 divided by A1 epsilon 3 1 minus epsilon 3 by A3 epsilon 3 1 divided by A3 F3 2 1 epsilon 2 divided by A2 epsilon 2. So this is the figure we can draw for this electric analogy. Further, from previous one, T1, T3, T3, T4 is equal to 27.33 divided by 25.55 or 25. T34 minus T2 to the power of 4. Further, we can write 2.08 T3 to the power of 4, T1 to the power of 4 plus 1.08 T2 to the power of 4. Okay, to simplify above equation like this, we can write even 1.08 T3 to the power of 4, T2 to the power of 4, okay, 1.08 T2 to the power of 4, T3 minus 1.8 T2 to the power of 4. Okay, further you can write like this: T3 to the power of 4 is equal to 1 upon 2.08 T1 to the power of 4 plus 1.08 T to the power of T2 is equal to 0.0, that is 0.48 T1 to the power of 4 plus 1.808 T2 to the power of 4. T1 to the power of 4 plus 1.08 T2 to the power of 4. So further we can simplify that equation called as 1. The heat flow, that is Q1 to 2, that is without shield. Without shield, Q1 to 2, T1 to the power of 4, T2 to the power of 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1 is equal to T1 to the power of 4 minus T2 to the power of 4, 1 upon 0.3, 1 upon 0.8, that is T1 to the power of 4, T2 to the power of 4, 3.58. You want to do this much. Okay, this equation you name it as equation number 2. Further, Q 1 to 3 for the heat flow with the shield, that is T1 to the power of 4, T3 to the power of 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 3, because the heat are 1 and 3, that's why that relation we have to consider, is equal to summation of T1 to the power of 4 minus T3 to the power of 4 divided by 1 upon 0.3 plus 1 upon 0.04 minus 1, then sigma T1 to the power of 4, T3 to the power of 4 divided by 27.33, equation 3. Okay, once if you got this, now you calculate percentage. Therefore, percentage reduction in heat flow due to shield, that is Q1 to 2 minus Q1 to 3 divided by Q1 to 2, 1 minus Q1 3 divided by Q1 2, again 1 minus sigma T1 to the power of 4, T3 to the power of 4, 27.33, sigma T1 to the power of 4, T2 to the power of 4, 3.58, 1 minus 3.58, 27.33, T1 to the power of 4 plus T3 to the power of 4 divided by T1 to the power of 4, T2 to the power of 4. Now further we can write 1 minus 0.131, T1 to the power of 4 minus 0.48, T1 to the power of 4 plus 1.08 T2 to the power of 4 divided by T1 to the power of 4, T2 to the power of 4. Okay, once if you find out this all the values in very simple manner, then again further you calculate 1 minus 0.131, substitute the temperature value, that is common, simplify this above equation, it becomes further the power 4 minus 0.48 T1 to the power 4 minus 0.52 T2 to the power 4 T1 minus T2 to the power 4. Further 1 minus 0.131 0.52 T1 to the power 4 minus T2 to the power 4 divided by T1 to the power 4 minus T2 to the power 4. Okay, so now this and this will get cancelled and we'll get 1 minus 0.131 0.52 will get 0.932. Finally, the percentage of reduction heat flow is 93.2%. 92.3.2%. This is the desired answer. Thanks for watching this video.